Remember biology 112? Just lie and say yes. Do you remember cellular respiration 112? Just lie and say yes. Do you remember the 3 steps of cellular respiration? Glycolysis, Krebs cycle, etc. Do you remember all the steps? Liars. Okay, so you are required in 200 level biology to remember all those. I'm not going to reteach you energy. What you're actually required now to know is the bigger detail, which is the enzymes used in those processes. So you'll notice that here's glycolysis, glucose to pyruvate. Here's Krebs cycle. Here's etc. Okay? You also notice that there are enzyme names listed above them. So you're supposed to know what enzyme kind of goes in which slot. Right? So I'm going to teach you enzyme family names, you're going to hate me, and where they go in the list. So some enzymes, like amylase and all that, have different roles. So kinase, does anyone know what a kinase deals with?
Phosphate.
It did very good. It deals with a phosphate group. All right. Dehydrogenase does what?
Removes the water.
Removes
Hydrogen.
an H. Very good. We're gonna cross off enolase. I'm not gonna care about that one. Can you guess what isomerase does?
Changes the...
Rearrange, makes an isomer. So makes an isomer, and mutase, do we know what mutase is? Makes it different. Makes a mutation, but it's not a mutation. Makes a change in a molecule. Okay, so if you just remember those 4 things, phosphates for kinases, hydrogens for dehydrogenases, and these 2 make it look different, we can actually fill in this whole thing using your skills as grade students. So we're going to slide this up, we're going to fill it in together, okay? We're going to try using our logic. So look at number 1. Look at step 1. Step 1, something to something, look here. There's a P on ATP. I wonder what enzyme would deal with ATP. Kinase. Because I'm dealing with phosphate groups or phosphates. So you would know that's a kinase. Okay, glucose 6-phosphate, glucose and fructose are almost the same. I wonder what we call number 2. Isomerase, very good. They're isomers of each other. You may not know that just by staring at it. That's isomerase. Yes. So number 1 is a kinase, number 2 is isomerase. Now, I don't know why this thing cut it off, but there should be an ATP here. Okay, so fill in ATP. So can you guess what number 3 is? Kinase, just like the one up above. Okay, we're going to skip number 4. You don't have to know. Number 5. I want you to look on the right-hand side of this equation and notice NAD what? H. Where'd that H come from? Somewhere in here. So what we call it when we remove H's?
Dehydrogenase.
That's a dehydrogenase. I'm removing hydrogens out of the molecule. So look at number 6 and tell me what 6 is. You should know this answer. That's a kinase. Very good. How'd you know that was a kinase? ATP. Right? You don't have to know 7. But 8 really, really changes the molecule. What do you think that is?
Isomer.
That's actually a mutase. And you wouldn't know that just by staring at it, but that's a mutase. And we're on our last one, which is just being cut off. Number 9. Anyone look at number 9 and tell me what that's going to be when I take a ATP? That's a kinase again. All right, so you have kinase, isomerase, kinase, dehydrogenase, kinase, that kind of thing. So by looking at that flow chart, if you can spot those enzymes, that's the goal. You do not have to memorize the words they're working on. That was 112. You have to just know the enzymes between them. I can hear the anger. We're going to do the same thing over here. Turn the page. And then I'll show you why this matters. All right, let's review. Dehydrogenase would do what?
Remove H.
Remove an H. Same name. Can anyone guess what synthase or synthase does? come together, combine, synthesize. Okay? I'm going to just cross these two off. I don't care if you know those. But this one, look at that word, kinase on it again. Can you guess what that's about? It's the phosphate again. So these are the same words you learned on the last page. Okay, now we're going to go through it. Look at number 1. Can anyone look at step number 1 and guess which enzyme that would be? It's a dehydrogenase. And how did you know that, besides all the H's there, right? It's dehydrogenase because it's H's coming out of the molecule. Look at number 9. Number 9 is added to this one to make that one, so you're combining them. Can you guess which one goes here? Synthase. Synthase is the enzyme to make number 9 become number 2. I'm combining. Okay. Okay, you don't have to know this one. Okay. Let's do this one, number 3 to number 4. Take a look at that and tell me what you think it is. Dehydrogenase. How'd you know that? Looks just like the one up here. It looks almost the same. Look at between 4 and 5. Tell me what it's going to be. Isn't that the same as this? Mm-hmm. Should it be dehydrogenase? Mm-hmm. Yes, it is. So those are both dehydrogenases because they look exactly like this one, which was a dehydrogenase. Okay, so look between 5 and 6. You're going to see something in a circle.
Thiokinase.
That's a thiokinase. That's the kinase one. Because that P. Okay, look at between 6 and 7. What do you see happen to the FAD? The FAD became FAD.
H. So G.
Oh, H's. I wonder which one does H's. That's a dehydrogenase again. Because I'm removing H's from the molecule. You don't have to know 7, that's fumarase. Can you look at 8 and 9 and tell me what you think that one is? Dehydrogenase. So if you notice on the Krebs cycle, they're almost all dehydrogenase. They're almost always removing H's from the molecules, which you learned in 112. So I remove H's, remove H's, remove H's, remove H's, remove H's. I added phosphate in here, I put them together. So there's basically 4 enzymes in Krebs cycle. Make sense? So the glycolysis had a lot of kinases. This one has a lot of dehydrogenases. Next page, the next one. One more to go. Then you can yell at me. The last one, ETC. There are only 3 enzymes. Look at that. Remind me what synthase did again.
Combine.
Combine. Okay, can anyone guess what oxidase does or deals with?
Oxygen.
Oxygen. Oxidase. And reductase is to reduce, which doesn't make any sense yet. But let's go through it. Can you find which of these complexes, 1, 2, 3, 4, or 5, do you think has an oxidase enzyme? I'll let you do the math.
4.
Number 4. And how did you know number 4 was the right answer? That's the only one that's got the oxygen right there. So this is oxidase. Number 4 is an oxidase enzyme, cytochrome oxidase C. Can you see any of those that combine things together? Look on the far right. See anything where we're making stuff?
ATP.
I'm making ATP in water. Wow, that's a synthetase. Because I'm producing, I'm combining. The other ones were all reductases. So everything in ETC is a reduction enzyme except for this one and this one. All right? So those are the enzyme names you'll have to keep in your head for your exam. If I were to give you these pictures, could you name some of the enzymes you see?
Would that be the only structure for the question? Would be these pictures? Yeah.
If I were to ask you to identify them on the picture, it'd be those pictures.
Will be like a written.
I would not intentionally try to trick you. I could ask you on paper what they do, what the dehydrogenase do. But if I ask you to name it and claim it, it'd be off that. Okay? Well, let me show you why you have to know this, future healthcare professionals. We'll do the easy one first. Scroll up a couple pages find this page here, number 21. This explains why you have to know this stuff. Okay, this is on the vitamins. So PCC says, thou shalt know the vitamins thou shalt. So we're going to take a little detour before we do this and write down the vitamins. There are 2 types. We're in a nutrition class. Can someone tell me the 2 types of vitamins?
Fat
Fat and
soluble.
water.
It's you. Fat soluble. And the other one is
Non-fat.
non-fat soluble, which we can call water. Good, let's review. What's it mean to be a fat soluble vitamin? Hydrophobic, I can be in fat, I can absorb into fat, I can be stored in fat, all those things. What's it mean to be water-soluble vitamin? You're not all that, right? So you're water-soluble, I can't be stored, I pee out. So, tell me which vitamins are what. So which ones are the fat solubles?
D,
A, D, E, and K. Those are them. So which ones are water-soluble? Everything else, so such as B's and C's and all the other ones. So for this class, that's a good list to know. We're going to go over here and write down what they do, because you're required to know what they're for. All right, so let's go through each one. So can someone tell me what vitamin A is for from last term? It's in carrots, and carrots help you do what?
Vision.
Vision. Very good. That's good for us. From Biology 112, can someone remind me what a B vitamin is for? For your brain, because it's a cofactor for metabolism. Do you remember what cofactors were? Just lie and nod. Okay. C is for
immunity.
immune cells. Very good. So again, it's a cofactor for metabolism. Okay. D, 231. What was vitamin D for?
Oh,
I can change your grade.
Calcium uptake.
Calcium absorption.
Could you raise my grade if you
No.
No.
Only drop them down. I never raise them up. E. Vitamin E. It's in all your lotions you pay a lot of money for. Collagen synthesis. Very good. Last one is K, which you did last term. Vitamin K is for?
muscle contraction.
No, that's potassium. Clotting. So there's the list on the test. I would ask you just to be able to give me those back. So you have to know which ones are which, fat or water soluble, and what they're generally for. Okay? But if you look at this case study, we're going to talk about vitamin B1, which is called thiamine. All right? So let's go down to question 1. Can you store thiamine? The answer is, let's find out. It's water soluble, which means you pee it out. You can't store water. You're not a camel. It doesn't work. So you cannot store. So not storable. The only ones you can store and hold on to are the ones in your fat. So vitamin B1, thiamine, you cannot store. Why? It's water soluble. Make sense? Okay. Now we're going to do this little kind of cuisine diversity case study I do. So we have 3 groups of people. In Malaysia, we have the Malays, some people from India, is that Tamil? Is that how you say it? Anyone know? I have no idea. Tamils, I think is what it is. And Chinese. Okay, they all live in Malaysia. What does everyone eat in Southeast Asia?
Rice.
Okay, they're all eating rice. Okay, so you have 3 groups of people all eating the same food. Notice the second paragraph. They cook it differently. Malays dehull it. The Tamils eat it parboiled by boiling in the husk. And Chinese, of course, eat polished white rice. So they have the same diet with 3 different ways of cooking it. Go down to here. So, the Chinese have a deficiency in thiamine. The Malays have some, the Tamils have none. So they're eating the same food in the same area, and the Chinese have the worst deficiency, the Tamils have no deficiency. All right? The only thing different is how they cook the rice. So you're going to go down to question 2. I'm going to give you and your group a couple seconds. Figure out why the Chinese were deficient and no one else. So go for that. See if you can figure out why that happened.